Hello, welcome to this A-level maths video. This is a pure mathematics video based on the year 2 content. We're looking at chapter 1 of the textbook, section 1.3, where we're going to introduce ourselves to partial fractions. So this is all to do with algebraic fractions, and to introduce this topic, what I'd like to do is ask you to have a go at the question on the screen. Pause the video, have a go at it, and then restart when you're done. Okay, so hopefully nothing too tricky here. Certainly you've done this kind of thing before. We need to find this common denominator first of all. This is how we're going to do this, and I think the easiest way of doing it is to choose the common denominator x plus 3 times x plus 1 here. And then in the numerator we have to multiply 5 by the x plus 1 to get the denominator of x plus 1 there as well. And then the 3 here is going to be multiplied by x plus 3. So we're going to end up with this here. Hopefully you agree with that. And we can tidy this up a bit because I can see that we've got a 5x minus a 3x in the numerator here, which becomes a 2x. And then 5 times 1 minus the 3 times 3 gives us 5 minus 9, which is minus 4. And that's, of course, still over the x plus 3 times x plus 1. And we can leave our answer like that. You get it right? Okay then, so I just want to pause for a second and just review what we've done here. What we did is we took two separate fractions, algebraic fractions, and we combined them together into a single fraction. And that's something which, you know, hopefully by now you're finding quite straightforward. You've done quite a bit of that before. What we sometimes need to do though is we need to be able to take a fraction which is like this, all combined, and separate it out into its separate fractions. And when we do that, we call that process finding the partial fractions. So here we go. Here's our formal definition. This is what we're going to be looking at in this video. If we have an algebraic fraction with more than one linear factor in the denominator, we can split that into separate fractions, each with a linear denominator. And that process is called finding partial fractions, or splitting that fraction into its partial fractions. So in our example here, if we'd have started off with this fraction here and then manipulated that to look like this, we would have found the partial fractions. So how do we do this then? Well, I've put the method on the screen here, but actually I'm not going to sort of talk through that in any detail now, because I think the easiest way to understand is to actually look at an example or two. So here's an example for us to have a look at together. We need to find the values of the constants a and b if the fraction we've got there, 3x plus 7 over x plus 2 x plus 3, is always going to be the same as a over x plus 2 plus b over x plus 3. Okay, so quick reminder in case you'd forgotten, this symbol here, the thing that looks a bit like an equal sign but with 3 lines in it, that tells us that this is true for all values of x. It's an identity we're looking for here. So we need to find the values of a and b, constants, so that this fraction, or these two fractions here, will combine together to make this one here. So let's look at the instructions then. The first thing it says, determine the form of the partial fractions. Well, actually, this is the form of the partial fractions. We've got two separate fractions with these two denominators. And the reason those are the two denominators is because when we combine these two fractions together, that's the denominator we're going to get over here, which matches up with this. So that's the first part of the process. Next, it says combine the partial fractions into a single fraction. Okay, so these are the partial fractions here. We're going to combine them into a single fraction, just like we did with the example that we looked at before. So the denominator here is going to be x plus 2 times x plus 3. Here we don't know the values of a and b, but we know that we're going to have to multiply a by x plus 3 and b by x plus 2 to get that common denominator. So there we've combined the partial fractions into a single fraction. Next it says we need to consider the numerator of the fraction to determine the values of any missing constants. So the numerators have got to match up here. The 3x plus 7 and this expression here has to be the same. And the reason for that is because the denominators, you see, we've got the denominators to match up, we need to get the numerators to match up as well. So what that means is we're going to have to find the values of a and b such that 3x plus 7 is always equal to a times x plus 3 plus b times x plus 2. Okay, following so far? Hope so. Okay, now there are a couple of different ways of doing this. The way I'm going to do it in this video is I'm going to use a method by doing this by substitution. There is an alternative way which is quite commonly used, which is by equating coefficients. If you want to see how that works, you can look in the textbook, because there are an example or two in the textbook which you can have a look at to see how equating coefficients work. But substitution, I find, is the way that most people find is easiest to get their head around how it works. So here's what I'm going to do. I'm going to choose a particular value of x, which is going to make things nice. Now, why can I do that? It's because this statement has to be true for all values of x. So in particular, it's got to be true when x equals -2. Now, you may see why I've chosen -2, or you may not yet, but let me substitute x equals -2 into here, and we'll see what we end up with. So 3 times -2 plus 7 on the left-hand side. On the right-hand side, we're going to have this number a times -2 plus 3, plus b times -2 plus 2. And maybe you can now see, if you couldn't already, what's going to happen. This thing over here, the -2 plus 2, becomes 0. And it means that this whole bracket here with this b term is just going to disappear. The whole thing, when we simplify it down, the left-hand side becomes 1 and the right-hand side becomes 1 times a. And you can see what's happened here. By choosing this particular value of x as -2, we've ended up with the value of a coming straight out at us. We know that a must equal 1 here. Pretty clever, right? So have a think, what other value of x could we substitute in to maybe make this bracket a 0 and leave just this term here? Have a think about that for a second. Okay, well, did you think of x equals -3 here? I hope so, because if we substitute x equals -3 into both sides, we're going to get 3 times -3 plus 7 here. We're going to have a times -3 plus 3, and then we're going to have plus b times -3 plus 2. And then just simplifying this down, we just end up with, what do we end up with then? -2 on this side. This term cancels out, and we just end up with -b here, which means that our value for b must be 2. And we've answered the question. Okay, so do you see how that works then? We've got our value of a and our value of b by choosing some suitable values of x here to substitute in. Okay, so please do go back and rewatch that if you think you need to. However, if you think you've got the idea, there's a question on the screen for you to have a go at now. See how you get on. Okay then, let's go through this one together then. So I've already made a start on this, so we can see that if we have given the form to us there, a over x minus 3 plus b over x minus 4, the first thing to do after that is to combine them together into a single fraction, like that. So hopefully you agree with that. Then, using our substitution method, we need to compare these numerators and work out what to substitute in. So let's start off. Now, hopefully you had the idea. X equals 3 is a good thing to substitute in, because it means that this b bracket here is going to become 0. But let's do it all so you can see what's going on here. So on the left-hand side, 3 lots of 3 minus 14 is what we're going to have. And then on the right-hand side, we're going to have a times 3 minus 4 plus b times 3 minus 3. And this all simplifies down to -5 on this side equals -a here. So that tells us that a has got to equal 5. Okay. Choose x equals 4, I think, is a good choice to find the value of b. So let's substitute that in here. 3 times 4 minus 14 on this side. And then we're going to have a times 4 minus 4 plus b times 4 minus 3 here. This whole thing here, why have I written a bracket there? I didn't need to do that. Okay, let's get rid of that. This whole thing here on this side becomes -2. And this whole thing on this side just becomes b straight away. So there's our value for b here. So hopefully you agree that a equals 5 and b equals -2. Now, there's no reason at all why we just have to just stick with 2 linear factors in the denominator. We could have 3 or possibly even more to deal with. It works in exactly the same way. So have a go at the question on the screen. This one's got 3 linear factors. See how you get on, but hopefully it's going to work out for you. Okay, let's see how we got on here. Now, I've already made a start here where I've combined the 3 fractions, the 3 partial fractions on the right-hand side, into a single fraction here. It looks pretty complicated and nasty, but that's what we've got. Hopefully you agreed with that. Let's work out what numbers to substitute in. So if we have x equals 1, the numerator on the left-hand side becomes 4 times 1 squared minus 15 times 1 minus another 1 there. And then the numerator on the right-hand side, well, I won't write it all out this time because hopefully we're getting the idea by now. But if you see here, the x minus 1 factor here and the x minus 1 factor here means that these whole terms here are going to just become 0. So the only thing we're going to be left with is a times 1 plus 2 times 1 minus 3 here from this term here. Simplifying that down, we end up with negative 12 on the left-hand side and negative 6a on the right-hand side. So that must mean that a must equal 2. So we're on our way. I won't put in all the details for the other ones here. I'm just going to jump to the answers. So when you substitute in x equals negative 2, after simplifying it all down, you should end up with 45 equals 15b, which tells us that b has got to equal 3. And then the other choice for x, which you should have thought of, is x equals 3. Simplify that down. When you substitute that in, you end up with negative 10 equals 10c. So that tells us that c must equal negative 1. So your final answer then, a equals 2, b equals 3, c equals negative 1. Now, so far, we've never had to actually find the form of the partial fractions ourselves. This has been something which the question has always given to us. But we do need to be able to do that in cases where we need to. So have a think about the question on the screen here. Hopefully you've picked up enough clues along the way so far. What do you think would be the correct form for the partial fractions for this situation here? Okay, so which one did you go with then? Well, we need the denominators to match up, don't forget. So of the options that are there, the second option there, a over x plus b over x plus 1 plus c over x plus 4, when we combine all of these ones together into a single fraction, the common denominator is going to be the same as the one over here. So this is the answer to the question. It's the second of those options. Did you get it right? Okay then, last question for this video then. Let's see if you can piece all this together now and do the whole process from beginning to end. You'll need to factorize the denominator of this one first, but once you've factorized it, work out the form of your partial fractions, then go through the process and get your answer. Pause the video and see how you get on. Okay, so let's quickly go through this one together. So the first thing to do would be to recognize that we need to factorize this denominator. And when you do that, you end up with x minus 1 times x plus 6. So that must mean that the form for our partial fractions must be some constant over x minus 1 plus some other constant over x plus 6. Now, of course, if you'd have written x plus 6 here and x minus 1 here, then it just means that your a and your b are going to be sort of reversed from mine here. It doesn't necessarily mean that you've done anything wrong, so don't worry about that if you wrote it that way around. Okay, let's go through the process then. So if we look at the numerators after we've combined these fractions together, we should see that 23 minus 2x has got to equal a times x plus 6 plus b times x minus 1. What should we choose for our x value if we're going to substitute in? Well, substituting in x equals 1, is going to be a good thing to do. And if we just substitute x equals 1, I'll just tell you that it becomes 21 on this side equals 7a on that side. So that tells us that a must equal 3. Substitute x equals -6. That's going to eliminate the bracket here. So when you do that, the left-hand side becomes 35, and the right-hand side becomes minus 7b, I believe. So that gives us b equals -5. And so we've been asked to actually express it in its partial fractions here. So the answer is going to be, let's just kind of go back up here. So a over x minus 1, a is 3. B over x plus 6, b was -5. So the answer must be 3 over x minus 1 minus 5 over x plus 6. And there we are at the end of the video. Hopefully that made sense, but if not, please do go back, rewatch bits, think about it, pause the video, stop and think if you need to, and get some extra practice by looking at exercise 1D of the textbook. There's a bit more work to do with partial fractions in this chapter, so please do make sure that you are really, really good at it. But for now, that's the end of this video, and I'll see you next time.